For statistical tools in finding difference, a difference indicates that the mean or rank, what is a rank again? What's the rank? Like ordinals, no? Of two or more groups are statistically different from each other, and the nature of the difference depends on the test you use and the groups you were comparing. What I meant with that? I mean that in any sample of data, there is no one standard statistical tool to use because there are many ways to treat data. But there is the most appropriate tool to use for a given data. There are different types of differences. The first one is the mean difference. The difference of the mean. Very self-explanatory, right? When comparing continuous variables for groups, a significant result means that the average value between groups are different. So if you have 30 grades of male and 30 grades of female, you are not actually comparing line by line. Okay? You are comparing the average. So it's called mean difference. That is why in many research papers, they will they will emphasize the data shows that there is mean difference of no because they are looking at the mean of all the sample. The other one is the distribution difference. This is actually for non-parametric test or categorical data. A significant result indicates that distribution of responses of rankings differs across groups. What does it mean to that? So for example, if you find a significant difference in satisfaction level between men and women, it means that the distribution of satisfaction is different for male and female. Or for example, more females may report higher satisfaction. Because you are now looking at the distribution of the difference of each. Unlike with the mean, you will just look at the mean. The computation in itself is actually looking at the mean of two modalities or two groups. While the distribution difference is line by line. Okay? But at the end of the day, I tell you, it will not matter. Because what matters most is your research question. Okay, so take a look at the research question. In my example there, those are the different ways to look at it. For example, if the average test scores of students in two different teaching methods, online versus in person, are significantly different. The other one is there a significant difference between men and women? This one, you're referring to two sets of respondents, the male and the female. Distribution difference. The main difference is you just need one set of respondents, but treated two times, in person and online. Gets now? What's the difference of the mean difference and the distribution? So that you can understand that well, let me proceed to the different statistical tool. The first one is the so-called independent samples, t-test, or simply called as t-test. Okay? So it compares basically means of two separate groups, independent. So, for example, two separate groups. Class A and Class B. Are they dependent or independent? Independent. Okay? Class A or class B. So characteristics of independent group. Different participants, Like for example, each group consists of different individuals. So for example, if you have two groups, males versus female, no individual can be in both groups. Okay? No individual can be in both groups. That is why called two separate groups. No shared experience. The groups being compared have been exposed to different treatments. Say for example, I wanted to study if there is difference of my discussion today between the in-person and the online. Two separate groups. One group is here, the other group is online. That is independent group. No shared experience. So, and then independent. The scores or measurements from one group are not influenced by or related to the scores or measurements from the other group. So for example, we have, is there a significant difference in the mean scores between class A and class B? Is there a significant difference in the mean scores between class A and class B? For another example, in my example a while ago, is there a difference in the level of understanding between my in-person now and on my online participant student? That's T-test. Yes? Okay. Now, the online calculator, let's use social science statistics. It's more accurate and easy to understand compared to Stat. Okay? Let's use our data that I told you to download. Let's use this data. The problem was class A and class B. Let's try to look at class A and class B. Where is class A? Here is class A. This is also class B. Okay? This is class A, and then this is class B. The question is there a significant, assuming this is assuming this is score, and then I already tested it, these are normally distributed. Both are normally distributed. Okay? So, the problem is there a significant difference between A and B? The score of A and B. What does it mean? It means that these are all the same students. Okay? From 1 to 50, I think these are 50 rows. So from 1 to 50 students, student A, class A, and then my class B. Is there a significant difference between class A and class B? So let's use, as I mentioned, let's just use this one. You can actually copy that. Copy so that you can paste it in your browser. Once it is now in your browser, you can see treatment 1 and you can also see treatment 2. The treatment refers to your groups. Okay? The treatment refers to your group. So I'll just copy A here. Copy A, right click, and then copy. Then you can paste it at treatment 1. And then copy again your B. And then paste it under treatment 2. Let's use again standard. In the future, let's always use 0.05. And then let's use two tails. Now, what's the difference now of two tails? Two tails means, remember in the bell curve, the one tail and the two tails. That means we are looking both, either the positive or the negative. Okay? Now, let's use two tails. Two tails is more relaxed, meaning there are more chances in finding differences. It's not that too stiff in the condition. And then just click T and P. And there you go. Just look at the bottom. It will just tell you that the p-value of this blah 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 and the p-value is 0.00, the significant at p blah blah blah. So what's the answer of the question? Is there a significant difference between class A and class B? Is there a significant difference? There is a significant. You don't say yes in research. You should say there is significant difference between class A and class B because the data shows that P is less than 0.05. Particularly, specifically, the P value is 0.00001. This is how to interpret the statistics and p-value are used to determine if the difference in means, again, is statistically significant. The Cohen's d can be used to understand the magnitude of the difference. For now, let's just skip Cohen. Cohen, remember we already determined that there is now difference. But the next question to that, if we will go into a more detailed problem, what's the condition of the difference? Is it high or low? Because they differ. Their score differ. Again, the p-value cannot determine with that. That is why we have to compute for Cohen's d. For the master's level, just never mind. Okay, I'm just showing it that maybe some of you will ask, so if that is statistically different, how good the difference or how bad, how high, how low? That could be answered by Cohen. Okay, but if the data is not normally distributed, now let's proceed to the Mann-Whitney U-test. Meaning, if the data is skewed, not normally distributed. That means your independent t-test cannot be used to that. So let's use the Mann-Whitney U-test. So what is Mann-Whitney U-test? It is a non-parametric test. Compares two independent groups again when the data is not normally distributed or ordinal. What is ordinal again? Like 1, 2, 3, high, low, very high, something like that. But the first thing that you should do is look at, even if that is ordinal, do not immediately work on Mann-Whitney U-test. Still look at the distribution. Okay? Then it runs the data rather than using the raw values to assess if one group tends to have higher or lower scores than the other. So when to use, ideal for small samples sizes and when data violate normality assumption. So in Mann-Whitney test, some of the application here, like evaluating satisfaction scores that are ranked and then differences between two teaching methods. For example, is there a significant difference in the satisfaction ratings between class C and class D? Let's try to look at our sheet. This is class C. Here. This is class. This should be class C. This should be class C. Or because we have pre-test. Or by doon na lang. Tama na. Class B and E. I'll just change this to B and E. The yellow actually there, those are skewed data. Okay? So skewed data. So we will use, in this case, I wanted you to use the use statistics and p-value determine whether the distribution of the two groups differ differently. So in the Mann-Whitney test, you can use this calculator. Oh, okay. I will paste it here. Oops, that's the same data. Here, I should copy class E. Again, we're looking at the difference between class D and class E. And the data is skewed. Then calculate, that will actually give you here just look at the bottom part, because if you will look at here, your p-value is actually equal to this one, your normal approximation, and the p-value is this one. Okay? So it means that that is significantly different. Okay? Just look at the p-value, which is equal to 0.00061004. Okay? So it is significant, it has a significant difference because the p-value is equal to 0.000. That's very small. So the first two, those are independent groups. Okay? Independent group. There is also a so-called comparing two variables that are dependent to each other. Two groups that are dependent to each other. So it's called paired samples, or your samples are paired and your samples are dependent to each other. So the statistical tool to that is paired samples method. When you compare two measurements taken from the same group or individuals. So the test compares the means of the same group at two different time points, or at two, or shares under two different conditions. And then, for example, is there a significant change in the rating before and after treatment? So one set, change before and after. That's how you're going to write a significant difference when your sample data are dependent to each other. So one group of respondents treating two different treatment or conditions. So like, is there a significant change in the rating before and after treatment? For example, I will ask you, is there a significant change in your understanding before the class and after the class? That's a what you call paired samples t-test, or because that is dependent. Your score one or your score of the post test will be actually treated versus your score during the pre-test. Pre-test, post-test. If there is difference, it means that there is significant understanding. But if there is no difference, that means wala pinasabtan. Because actually, that's it. When you give pre-test and post-test, for example, if I will say, what is your level of understanding before the exam about statistics or about comparing two values? You said in the first, during the pre-test, you said 4, 5 is the highest. And then in the post-test, you said 4. In descriptive statistics, that's not necessarily, there is no difference because that's equal to 4. But if statistically, when there is difference, the 4 and the 4, even if numerically they are the same, but if statistically they differ, it means that your 4 in the post-test is different from the pre-test. Yes? Okay. Another example, what if in the pre-test is 4, in the post-test is 3, and the result is not significantly different? What does it mean? Even if 4 imuhang understanding or knowledge level, and then post-test na 3, I don't care, because that's the same. But if there is a significant difference from 4 to 3, it lows, right? Meaning, you get more confused because there is difference from 4 to 3. The difference is 1. The one there, that there is significant difference in your understanding. Okay, so the effect size measures the magnitude of change. Assumption, the differences between paired observation, again, should be normally distributed. Let's try to solve it. Is there a significant difference in the mean scores before and after treatment of class C? Let's try to look at this. Class C, yes. Post-test treatment, class C. Let's try to look at class C, class C, class C, class C. Here, this is class C. Pre-test and the post-test. The same class. Score, class C pre-test score, that's the same student with a class C post-test score. So this is class C pre-test and class C post-test. Let's try to see if there is significant difference. Maybe just imagine that this is my class. And then I ask you what's your score from the pre-test, or is there a significant difference of the pre-test and the post-test? Okay? So how to do that? I wanted you for this time still use statistical. Okay. So let's look at statistical. Okay. So all we have to do is to select class C post-test score. You have to select that and then paste it into your before. Share. Okay. And then the class, sorry, it should be pre-test. Pre-test should be placed on the first before, and then the post-test, I will paste it here. This is pre-test and this is the post-test. Calculate. So the p-value is 0.00041. That means, is there a significant difference of the score of class A or class C during the pre-test and the post-test? There is a significant difference of the test scores of class C between pre-test and post-test. Let's proceed. So the next question is, what if the data is not normally distributed? Huh? I'll introduce another one, the Wilcoxon signed rank test. Okay, so Wilcoxon signed rank test, a non-parametric test, when the assumptions of your paired sample t-test are not met, meaning skewed ang data, not normally distributed. So it assesses whether the mean differences between paired observations significantly differ from zero. When to use? When comparing two related samples or repeated measurements that do not meet normality assumption. So just think of that. If the data is independent and if normally distributed, paired, t-test or the independent samples t-test. If the data is independent and skewed, then you will apply Mann-Whitney U-test. If the data now is paired and it is normally distributed, apply now paired t-test. But even if the data is paired but not normally distributed, apply now Wilcoxon sign rank test. So for example, comparing stress level before and after a mindfulness intervention among the same groups of respondents. Okay? So for this, I wanted you to use the Stockholm statistics. It's easy to understand compared to Kingston. So let's try, there's one. Let's try the pre-test and post-test, class F, no? Or our satisfaction, let's try the satisfaction. The satisfaction of class A before treatment or before intervention, and satisfaction of class A after intervention. These are or class F or this one also. Let's try to do this here. I will select this one and let me check here. Is there not yet? I will paste outside statistic. These are the direct link so that you won't anymore find them. And then I'll work with class F. Class F, pre-test and class F post-test. So I will select class F pre-test and then paste it at treatment 1 there. And then I will copy class F post-test and then paste it on treatment 2. Let's use 0.05 and again always look at the two tail instead of one tail. And then click calculate. What's the result now? In the result, just look at the bottom part that the value of Z is negative 5.43. The P value is less than 0.001. Okay? So, therefore, there is significant difference. So, the just use this calculator. I think you don't have a problem in this calculator. All you have to do is really understand your data and at the same time understand the research question. The first thing to do, calculate if that is normally distributed. If the KS test, if the P of the KS test is greater than 0.05, it is normally distributed. Then, if that is independent, go for t-test. If that is dependent group, go for paired test or paired samples t-test or paired t-test. Okay? And then, if when you compute the KS test and if P is less than 0.5, it's skewed data. Therefore, if that is independent group, use Mann-Whitney. And if that is paired, use Well-Boxon signed rank